Hi everyone, welcome back to Coding and Analysis. In the previous video, I ran the random forest classification with cross-validation model to determine a classification for the play more than 14 column. And you can see here we made a function and with if statements and else if statements to assign a risk tier, and then for this adjusted risk up here. Based on this adjusted risk, we're applying the logic for the risk tier. So that's going to show up in our results. And then, so the adjusted risk is this plus the age plus the health grade. And then the risk tier is what the words are going to be, how they're going to correspond to the numbers. So this is the number, and this is the words that's going to correspond to the numbers of the adjusted risk column. And then so we run it. We run the train classification model function, and then we get concatenate to one data frame, and then we're creating a dictionary of overload data that we want to put into the data frame. So we're saying Tank Dell, he's going to be out for the year. He's not going to play 14. He's not predicted to play 14. And then we're going to keep his adjusted risk at 5, and his risk tier is significant because that was the calculated score. We're just putting these to 0 since he's not going to play. Then we're going to loop through each player and their override values in the dictionary. And then we're going to loop through each column key and the value that you want to override. And then we're updating the data frame with the player. So once it reaches Tank Dell, it's going to apply all of this, and it's going to override the data to show that he will not play more than 14. He's not predicted to play more than 14. And then we print out the results. These are the results. So we have an accuracy score. That's how accurate the model saw the classification results. So for running back, it was basically 83% accurate, the results. And then the wide receivers and tight ends, the results the model got were 90% accurate. And for the quarterback, the results were 84% accurate. And then you can see here there are these other metrics like precision, recall, F1 score, and support. So down here, I'm gonna have this in the show notes as well. These definitions where you can go find them that I put together. So the binary target, just going back over this, the binary target 0 will not play more than 14 games. 1 will play more than 14 games. And then the precision score of all the players the model predicted would play more than 14 games, how much or how many actually did. So high precision means few false positives. So it's a high precision for really all of them. So we're saying that will not play more than 14 games. It was precise on 84%. And on will they play more than 14 games, the model was precise 85% of the time. So that's, anything in 80% is pretty good. 90% would be great. 70% would be decent, okay. And then the recall score of all the players who actually played more than 14 games, how many did the model correctly catch? So if we're getting a high recall means few false negatives. So really, how many real positives did the model successfully find? So can see here, there's a high recall for really all of them. The lower recall, lowest one was for the quarterbacks where they played more than 14 games. So it only recalled it 73%. So there were some false negatives. I wouldn't say there are a few. There were some, since the score was 70, since it was a 73. Then if we go to F1 score at the balance between precision and recall, a single score that balances both precision and recall. So you can see here the wide receivers and tight ends, they scored the best among the positions. And then all this is just gonna come together. You see with the accuracy right here, that's what's showing up here. And then you can see the macro average, the average of precision recall and F1 treating both classes equally regardless of size. Then the weighted average, same metrics as the macro, but each class is weighted by how many players it has and is more reflective of the overall performance across the full data set. So for the weighted average would be probably it'd be more important. So you can see here, yeah, the weighted average for precision recall and F1 score is 84, and that's where we get the accuracy 84. Weighted average is 90, and then we're getting it 90 right here. And the weighted average is 83, so we're getting an accuracy of 83. So these are pretty decent scores. And support, lastly, support just means the number of true instances for each class. So the actual examples. So there were 47 running backs that were not predicted to play 14 games, and there are 41 that are predicted to play more than 14 games. So wide receivers, tight ends, 60 are not predicted to play more than 14. 95 are predicted to play more than 14 games. And then you can see here, quarterbacks, it's a lower amount. The 23 are not predicted to play more than 14. 15 were predicted to play more than 14 games for the upcoming 2025 season. So these 15 are most likely the starters, and the backups are mixed in between here. So you can see here, we're gonna chart the accuracy scores. So the running backs, wide receivers, tight end, quarterbacks. So I'm just getting this information and putting it into a data frame, and then putting the F1 data into the data frame. And then we're plotting it out, and then the bar plot with Seaborn, with the y-axis as accuracy, the x-axis as position. So it's just to reinforce what we already showed here, but it's just a better visual representation of it. So you can see here the wide receivers and tight ends had the best accuracy, 90%. Quarterback had 84, and then the running back had 83. So 83, 84, and 90. So really the fun part is just to going through and look through the CVS spreadsheet and the CSV spreadsheet of the football injury classification results. So you can see Jamar Gibbs, he is expected to play more than 14 games right here, and then he based on the the 3-season average, he most likely play more than 14 games. And his adjusted risk is 1, so his risk tier is low. I love looking at these risk tiers and their adjusted risk. It's really fun. So you have Kyren Williams, the average for the past 3 seasons. So he's not predicted to play more than 14. And then our model agrees and says he's not going to play more than 14. And he has a adjusted risk of 3 and a risk tier of moderate. So you can take this CSV file and research for your upcoming fantasy football drafts. It's probably the most helpful of all these um, models that I've completed in this playlist, this health data set for the NFL players. And this one's interesting. So Brees Hall, based on his average 3 seasons, is not predicted to play 14, but our model says he is. And our adjusted risk is 1, so his risk tier is low. Let's go look for one that's a high risk tier. So Zach Moss. So he did not play. He's not gonna play more than 14 based on his 3 season average. Our model says he's not gonna play more than 14. He has an adjusted risk of 5 based on his injuries that he's had past couple of years. So his risk tier is high. And then Khalil Herbert, the same thing. He has had injuries the past couple of seasons, so he has a high risk tier. So 4 and 5 would be considered high, and 2 is minor, 3 is moderate, and significant is 6 or greater than that. So Keaton Mitchell, he's this past couple of years, I think his rookie year was last year. He got hurt last year, and he was still hurt from last year in the 2024 season. I think he tore his ACL, so he didn't really come back. So his adjusted risk is 6, and his risk tier is significant. But then you can see here that the rookies coming in, 2025 rookies, it's just gonna say 0, even though it would be it would it should say 1 right here, but since they didn't have any information in this column, it's just going to be 0. But you can just basically just look at the adjusted risk and see that their risk tier is low, and just based off the upcoming rookies, just focus on these 2 columns and not these 2 columns, since they haven't played it at any games. And then you can see Elijah Mitchell. He had a health grade of 29, I think. So his adjusted risk is probably the highest number of in this CSV file, and his risk tier is significant. And you can see Jamar Chase. He's predicted. Our model says he will play more than 14, and the 3 season average says he will play more than 14 games, and he has a low. He's in the risk tier of low and adjusted risk of 0. So that's good. That's probably going to be probably the number 1 draft pick in the this upcoming fantasy football drafts. Probably 1 or 2 or 3. He's going to be up there for sure. And then see Justin Jefferson. He has a minor risk tier and an adjusted risk of 2, but he's expected to play more than 14 on model. And the 3 season average said he was expected to play more than 14 as well. Let's look at the quarterbacks over here. Oh, let's look at Kyle Pitts. So he is expected. Our model says he will play more than 14, and his 3 season average says based on that, says he will as well. And then the adjusted risk is 0, so risk tier is low. If you wanted to draft Kyle Pitts as your tight end. And then quarterbacks, let's look at the quarterbacks. So I think there was more of a, the recall was at a 0.73 score, so there was more misses in the quarterbacks for some of the players. So like Drake May. So our model says he will play more than 14, and his risk tier 0 and low. And then Kirk Cousins, which he'll probably just be a backup. So they're not expecting him to play 14, which makes sense. And he has a risk tier significant. So is Aaron Rodgers, just him, I think he's 42. So I'm just not quite sure if he's going to play more than 14 games with his age. And he is in the significant risks tier. And Patrick Mahomes, Patrick Mahomes, he has a low risk tier and adjusted risk is 0, and he's predicted to play more than 14 games. So you could really just spend a lot of time just looking at this and seeing, kind of just basing off of basing this information on how you want to approach your fantasy football draft. So that will be it in this video, and this will be the last video in this playlist. Before I go, I just want to look at Jaden Daniels. So the 3-season average. So he only had 1 season last year. So I think he played 16 games or 17 games. But our model predicts that he will not play more than 14, even though his adjusted risk is 0 and his risk tier is low. That's very interesting. But yeah, let's go back to, so this is the last video in this playlist for the health grade data set. And the next project, what I'm planning on doing is using models, looking at the actual fantasy football points instead of the health stats of the player. So it's going to be more of their fantasy football stats using random forest regression and cross validation, and maybe I'll add some XG boost as well. I'll do some XG boost models. So hope you stick around and watch those videos when they come out. And thanks for watching, and like and subscribe and leave a comment about if there's any football players you're thinking about most likely drafting just based on their health, statuses, and maybe look at this and look at their risk tier. And always remember to never stop coding, and thanks for watching and have a good day. Bye now.